Okay, so today what we're looking at is parallel and perpendicular lines. So our goal today is I can write equations. So we're still writing equations using the information from the last three lessons, but we're going to be talking about very specific ones, parallel or perpendicular lines, using the information they give us. So first of all, let's look at parallel lines. Okay, so that's part one. First of all, one thing that you should know about parallel lines, they never cross. Okay, they don't intersect, they never touch each other, so they're parallel. There's the same distance between all of them, so the same distance all the way. Okay, so I could take that and clone it and take it, and it would fit in exactly the way the other ones did. So the spacing between those points does not change. Okay, so that's why they never cross. Now, the where I actually created this graph was from this website. So you can actually go to that website if you want, and you can fool around with it. I chose that one over the graphing calculator because it's a little bit harder to see the graphing calculator. Sorry about that little glitch there. I thought I had paused you, but I hadn't. Okay, so what I did is I made the screen a little bit larger for you. So you can actually go to that website if you want. Okay, so these specific lines actually came from there, and the red one has the equation y equals 2x. The blue one, sorry, the red one has the equation y equals 2x plus 4. The blue one has the equation y equals 2x. And the green has the equation 2x minus 3. So actually, I do have that website up here, and there's the one equation. Then I had 2x, oops, sorry, I've already forgotten, 2x plus 4, and the other one was 2x minus 3. Now, when I go to actually make it graph it, so I'm plotting it, you'll see that the screen that I have, as soon as it finishes loading, is the same as the screenshot that you have. Now, if I want to make a fourth one so it's parallel, let's take a look at the equations. What do the equations have in common so that I can create the fourth one? Well, I can see that all of them have a 2x in them. They have little different things over here. So it appears that if I have a 2x and then something else, it should be parallel. So let's try 2x and let's try negative 5. Okay, so we're going to plot it, and then I'm going to go back up here and see. Wow, so this one, this orangey yellow colored one, is parallel to the other three. So you can see what they had in common was the 2x. Now, what exactly is that 2 that's in front of the x? Well, it's in the location of the slope, because we know that the slope, and I'm just going to bring up my pen, we know that the slope is y equals mx plus b. So we can see that where the 2 is in the location of the slope. So we actually have discovered something. We have discovered that, first of all, how are they the same? Well, they're the same in the sense that they all have the same slope. Okay, they all have the same slope. What's different about them is they intersect the y-axis in different locations. Okay, and if I go to the bigger one, it might be a little bit easier to see. You can see this one crosses at 4, this one at 0, this one at negative 4, sorry, negative 3, and this one at negative 5. So they're crossing the y-axis at a different location as well as the x, but their slopes are identical. Okay, so how are they different? The y-intercept's different for all of them. Okay, so what we can conclude from this is that if the slope is the same, then the lines will be parallel. So if I recognize that the slope is the same, that means those lines will be parallel to each other. So this is the type of mini part of what type of question you'll be asked to do. So it says find an equation that is parallel to y equals negative 3x plus 6. Now it says the word an equation. The reason it's an equation because going back to here, I have four that are the same. I could come up with more as long as I had the 2x there. Okay, so if I plot that, it's going to be the same as well. So I could have infinite choices here, infinite choices, as long as my slope is the same. So that's what we're going to do. So with the pen, so what do we need? We need to, first of all, find out what our slope is. Well, here's our slope here. So from y equals mx plus b, I can see that my slope is negative 3. So as long as I create equations with the slope of negative 3, I'm correct. So my answer is y equals negative 3x, or I could have another one and it could say y equals negative 3x minus 4, y equals negative 3x plus 10. So again, as long as I have each time that negative 3, it's going to be parallel to that equation. Okay, so parallel, the slopes are equal. Okay, now what we're going to do is we're going to look at perpendicular. Now, first of all, perpendicular means not only will the lines intersect, but at 90 degrees. Now, I will admit that it's really hard to tell from the pictures here that that is actually a 90 degrees. And actually, if I measured it, it wouldn't be 90 degrees. And the reason is, if you look at the squares on this grid, they are more rectangular rather than squares. Okay, so if they were squares, it would come across as being 90 degrees. Now these squares here are a little bit more like they are squares. So let's try the questions that I have here. So take a look at, and I'll tell you what they are. The first one is this, y equals 2x. And then the red one is negative 1/2 x plus 6. So I'm going to try that. So 2x and negative 1/2 x plus 6. So those are what I have, and let's plot it. Okay, so now if you actually look where they intersect, it does look more like a 90-degree angle. Okay, so they will intersect at a 90-degree angle. So now if we go back to the next one, its equation, the blue one is negative 1/3 x, and the red one is y equals 3x. So to find perpendicular, well, obviously they're not equal, the slopes aren't. Is there something else that can help us? Okay, so we have y equals mx plus b, oops, mx plus b. So obviously our slopes are not equal. Are our y-intercepts equal? No. Well, this one is. They're both equal to 0, but that doesn't help me. This one, they're not. So hopefully you recognize that there is something going on with the slopes. So let's take a little bit closer look, and I'm going to use the blue for a second because we're actually kind of discovering what that would be. Okay, the slope for this one is 2, and the slope for the perpendicular one, and the little symbol we use for perpendicular looks like this. I don't know if you've seen that before. Kind of looks like an upside down T. Now its slope is negative 1/2. And if I look at the slopes over here, this slope is negative 1/3, and this slope is 3. So hopefully you're starting to recognize a pattern. One's positive, one's negative, one's negative, one's positive. So it looks like the sign, whether the positive or negative, is important. And then if you notice, if I take 2 and reciprocate it, so in other words, flip it, that would be 1/2. The reciprocal of 2 is 1/2. The reciprocal of 1/3 is 3. So actually what we have found is that the slopes are opposite signs and are reciprocals. And we call that negative reciprocals. So they're negative reciprocals to each other. Okay, now using that information, we're going to do some calculating. Okay, so here the first one says find an equation of a line that is perpendicular to y equals 5x plus 3. Okay, again, there's an equation. There are infinite equations that we could find. All right, so let's go back and get a writing, something to write with. So the first thing I have to do is I have to determine what my slope is for the original equation. So this is what I'm looking at. And so I can see that the slope of this line is 5. That means then that the slope of the perpendicular line to this would have to be, this one's positive, this one would have to be negative. Reciprocal of 5 is 1/5. So now all I need to do is create an equation. Y equals negative 1/5 x is the simplest one. Or I could choose y equals negative 1/5 x plus 1,000. That would be one as well. Obviously, I probably wouldn't choose really large numbers, but it works. Okay, so let's look at the next one. The next one says y equals negative 3/4 x minus 6. Now remember what I'm after? I'm after perpendicular to that line. So again, I'm looking at this and I can see that my slope of this line is negative 3/4. So that would tell me then the slope of the perpendicular line would be, this is negative, would have to be positive. I need to reciprocate 3/4, so it would be 4/3. Using that information, I can come up with infinite equations. And again, we're going to use the most simplest one first, followed by some crazy ones. So y equals 4/3 x minus 44. Okay, so what happens is I can choose whatever I want for my y-intercept. However, my slope has to be negative reciprocals to the one I want to try. So now what we're going to do is we're going to look at some examples that have a little bit more to them. So I'm going to stop the video and then we're going to come back and complete these two examples.